University, and then she has traveled widely. As far as I can see, she has traveled widely and has been to different observatories also. So one of the things which I have to tell is the person who has worked at Hanley for a lot of observation. Yes, but the Hanley observation, most of it happens at Crest.
Yes,
That is
yes.
of IIA, where people don't have to reach Hanley, but they can sit in Crest in Bangalore and see the sky. So this is one recent advancement that you can see the sky of Hanley from Bangalore also. So I think she has also published some books with the Birla Institute of Fundamental Research. I have a copy of that also. And the best part of today's talk, she is going to tell us about comets and how the little of maths is going to be applied for comets. It's just not comets by tail. As she rightly put up, comets are like cats, but cats have only one tail, whereas comets have more than one tail.
Yes.
So I think, Dr. Margarita, the uh, online session is for you, and we definitely look forward for your talk at Bombay also, and you be our guest. And also we look forward to meeting you in person. It's not that we have astronomers, as Professor Bapu, which I had told you earlier, he had always told us that anyone who does astronomy is a part of our family. And Amrutanshu has already made some nice program 2 3 years back on Bapu also. So I think we all have a great regard for you as a part of our family member. So you
Thank you.
please, we are all looking forward to hearing from you in this festive days, and especially any new activity in astronomy we want to start with you. So, with
I'll be
these
happy.
words, I request Dr. Margarita to give us this wonderful talk.
Thank you for your introduction. Oh, one second.
Yeah,
I hope I'm sharing my screen and you can see. Is it visible?
No, ma'am. No, ma'am.
No? Oh, strange. One second. Then I'll try again. Because just now it was okay. Now again. Mhm. Okay. I hope now it is visible.
Perfect, ma'am.
Yeah. Okay. So yeah. Sorry. Is it okay? You can see everything.
Ma'am, Mangesh sir is just giving requesting you to click on the hide part. There is a hide. There is a message na at the
Hi.
bottom of the
Oh,
screen.
oh, hi, hi. Oh, yes, 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 yes. Sorry. Yes, yes. Okay. So, what can we learn from comets? And what can we teach using comets? Okay. David Levy will us comet hunter comets like cats. They have tails and do exactly what they want. And that's actually true. We still have problems predicting completely the comet's behavior. But then you would think, okay, why comets? Why we talk about comets and not, let's say, stars? Because comets are, Well, here I have a set of uh, comets are very pretty. But there are more profound reasons. Image, just an image of the companion, but just as a largest object in the solar system. Can somebody volunteer the answer? Okay, somebody please say what is the largest object in the solar system?
Sun.
Amritanshu, please speak. Please tell me. Good
Sun.
answer, but actually not. Nope. Comets are the largest objects. They can be the largest objects in the solar system. But in November 2007, its comet became larger than the sun. The Great Comet of 1811 had diameter 50% larger than the sun diameter. Here is the image. And of course, this is just common, not to say about tails. Just look at the tails. We all know how huge a million kilometers. They're not just million kilometers. They can be astronomical unit long. For example, Comet had in 2002, IKEA Zhang had a tail of at least 7.5 AU. Distance to Jupiter is only 5.2 AU. Then comets are also fast. This is the image of the from Soho of the comet. But I want to ask one more question, trivia quiz. What is the fastest object in the solar system? Can somebody volunteer the answer? Please, please be active. Please, please. Mercury. Ah, this is a good answer. Yes, but when we look at actual speeds, like Earth, Mercury, asteroid, Parker Solar Probe, which is like the fastest uh, man-made object, but comets are the fastest object in the solar system, especially sun grazers. Sun grazer at perihelion can have the speeds of more than 500 kilometers per second. It is fast. How fast is that? Actually, I'll show later the calculations. It can be 0.2% of speed of light. You can even say, oh, this is nearly relativistic. And one my student, when I told him that, he said, oh, maybe we should think about what relativistic effects can be produced by that. Who knows? It is an open area. Nobody ever thought about it. Comets actually are also solar wind probes, and this is very important. For example, this Lovejoy comet, we can see how it wiggling in invisible magnetic lines. And this, this particular effect actually stimulated a lot of investigation from the scientists. That detection of the solar wind speed near the sun is significant in understanding it. And plasma tails of comets have long been used as natural probes for the solar wind speed. And here are, for example, the recent papers about how to use observations of cometary tails to infer solar wind speed. Comets, of course, are very beautiful. Everyone can agree with that. Most important, their remains give us beautiful phenomena: meteor showers, noctilucent clouds, and zodiacal light. These are the images of course, showers, zodiacal light, noctilucent clouds. So the point is that there is a lot of space dust, and most of it is falling on Earth every day, more than up to sometimes 1,000 tons. In the last 24 hours, for example, millions of meteors with sizes from grain to sand to basketball fell on Earth, and most of them are remnants of comets and asteroids. Meteors, we know, are comets remnants. 70% of space dust that is found between, sorry for the for my typo, is found between the Sun and Mars actually comes from comets. So meteor showers are comets remains. This is very interesting. This is very interesting website, meteorshowers.org. Very informative, and you can visualize the meteor showers by looking around. It is very good. I highly recommend this to just play around. So meteor showers, comets remains like Halley's comets returns to us in bits and pieces. Last time, actually, it visited us in 86, but annual Orionids meteor showers are pieces of it. And Perseid meteor shower are remnants of Swift Turtle comet. And Leonids, of course, dust remains of Temple Turtle, or comets like Ison, for example, Ison of 2013. can only cause the phenomenon of so-called noctilucent clouds, very high atmosphere cloud made from water ice crystals, which are seeded by comet's dust. This is a photograph of noctilucent clouds. And zodiacal light is a glow in the sky produced by the reflection of the sunlight by the cometary and asteroidal dust. There is some new result that suggests that some of it can be also a Martian dust. It seems that Mars loses a lot of has a tail in a wake in its wake, just like a comet nearly. So that some of the zodiacal light is actually Martian dust. So comets are also very profound. The nuclei contains a variety of organic compounds, methanol, hydrogen cyanide, formaldehyde, ethanol, and so on, and even more complex molecules, like even amino acid. For example, while 2 Comet, the spacecraft Stardust found glycine, which is extremely important amino acid for life. So the existence of complex organic matter on Earth is difficult to explain if we consider the Hadean Earth. Hadean Earth means it was mostly molten. Earth was accreted from matter with temperatures, very high temperatures, hence there are no volatiles like CO, CO2, or water, it would have evaporated. Just when it cooled, the moon, the tear impact, moon making impact, and late heavy bombardment happened. Again, so here I try to put the Earth timeline and millions of years ago. So Earth forms from a vast cloud, then giant impact forms the moon, then late heavy bombardment, and already early life at nearly 4 billion years ago. So where is the organics? Where that came from? So flux of organic matter on Earth during the late heavy bombardment could be as much as 10 trillion kg per year. Comets also brought water and nitrogen. There are several research, several papers which actually show here that high impact shocks do not destroy those compounds. They actually create amino acids. They form dipeptides, the peptide bonds, which are actually the precursors of proteins. And recent paper has shown, can comets deliver prebiotic molecules to rocky exoplanets? That actually, comets are so important that they may go around and move the prebiotic molecules and maybe even biota around the stellar systems. They may be seeding the life, like what we call panspermia. That there is a theory that life on Earth originated somewhere else and was brought here by these interstellar comets. And what about water? It was initially thought that water was indigenous to Earth, but water, of course, when the Earth was molten and after the impact, it would have been gone. Thus, it must have been brought to Earth by comets about 4 billion years ago. But which comets? So there were calculations that in a short period comets, the observatory, Herschel observatory, measured the ratio of deuterium to hydrogen. And it was found that cloud comets, they have a paper about it, and they made the plot, and they said that some Jupiter family comets, they can bring water to Earth. And most important, that comets do have water and do bring water to planets was shown in 1994 by the beautiful example of Levi-Shoemaker comet. This paper calculated that 95% of water seen in Jupiter's atmosphere actually came from that comet. So comets are fun. Everyone can agree with that. So what is a comet? So we can call it a loose conglomeration of ice, rock, dust, and organics, which is very, very important. Organics, a dirty snowball. Here is the structure of the comet: nucleus, coma, surrounding cloud of dust and vaporized gas, hydrogen cloud, and the tails. Of course, there are two, like you as observers know that there are always two tails at least. Comet has two tails visible: dust tail, which are dust particles, ices, reflected solar light, water also, water vapor, and ion tail, which is ionized gas, which follows magnetic field, or let's say solar magnetic field, and responds to it. Mostly it is ion, it is and CO plus, because CO plus we know it scatters blue light better uh, than other lights, like than white. So that is why it actually looks blue. And here these are my images of last year's comet ZTF E3 in different filters. This is from Hanle. This is in B filter, V, and R. And in B filter, that straight ion tail is very well seen. And this is the same comet later, and in March, and this is the dust tail. And the dust tail follows the orbit, so it actually curves. Here you can see that it curved very weirdly. Like here it is there, you can see it like this, very strange. But it curves following the orbit, unlike the ion tail. So where do the comets come? Where do the comets live? So long period comets, they live in Oort cloud, and short period comets, they live in Kuiper belt. Oort cloud comets, the estimated total mass is about 100 Earth masses, and they believe to have trillions of comets. It was discovered roughly in 50s, but suggested that in 1932, Estonian astronomers suggested that there should be a constant replenishing reservoir because comets come and come and come. Where they come from? And in 50s, finally, Dutch astronomer Oort showed that there is a distant source. And the same famous comet hunter David Levy said that the Oort cloud is the result of a long game of interplanetary pinball. They are very important because their composition is supposed to be the pristine material, never reheated. So, but by now we know that there are interstellar comets, like for example, Borisov comet. How do we know that they're interstellar? Later I will talk about my book, why calculating the speed of the comet is important. So this comet was moving too fast. What does it mean too fast? That is, it was moving too fast to be a member of the solar system. From IU, as IU said, based on available observations, the orbital solution for this object has converged to the hyperbolic elements, which would indicate an interstellar origin. The other indications were much higher velocity than usual solar system comets, and its orbit at nearly the right angle. So we can compare the velocities, inbound velocities of different objects, like for example, ISON, Oort cloud comet, Voyager, for comparison, Oumuamua, which was also interstellar, and Borisov. It was 32.2 kilometers at this distance. So it was much higher than the escape velocity from the solar system. So, but actually we know that there are lots of exocomets. Here, in case anyone is interested, that there are exocomets which actually have been detected. They have been detected in first exocomet was detected in 87 about Beta Pictoris. And by now, there are about 27 stars around which the exocomets have been observed or suspected. Most of them are young A star, but exocomets also were discovered around F-type stars and late B-type stars. Some were actually detected by citizen science volunteers using Planet Hunter project. And even the new method was suggested to search for transits in Kepler data in this paper, which if anyone is interested in this citizen science Zooniverse, Planet Hunters project, this paper is automated search for transiting exoplanets using Kepler's light curves. It's very interesting. And it also explains how the transit of the comet is different from transit of a planet. And it seems that it is a very clearly different. So, what can we teach using comets and how? Well, by now we know that astronomy is drowning with data. The field of, as you know, that the solar system missions, survey data, all radio, all kind of range of electromagnetic spectrum, gravitational wave detectors, simulations. So the field of astronomy started to generate more data than can be managed, served, and processed by current techniques. And there are very few actual professional astronomers in the world. Most of them we know by name, or personally, or at least by name. So 60 years ago, scientists could count sources in a radio survey by hand. Now it is impossible for the data streams are in terabits per second. And then there is already existing data. So astronomy actually experiencing the data tsunami. And what can we do with that? What can we do? There are not enough astronomers. So we have to communicate this data to people. So of course we use this data. We astronomers, we write papers, theses, give talks, seminars, but most of the time the data is stored and the public doesn't see it. Public doesn't see it because of humans. Public retain in it that original nitty-gritty data which is at the core of any astronomical work remains unknown to the public. And then very often, after being used for papers, the data is stored and that's it. It's archived. There is archival data for more than 100 years. To use it in our outreach, in teaching, in other words, is it possible to communicate the data to the public and then let them use it? So here I wanted to talk about the data which I used of the comet Ison, which we observed from January to October in 2013, and with my co-author is 11th grade student at that time. He was amazing, very smart boy. He's now finishing MIT. So we've written this. We use the data to write a small book on mathematical fun with comets. So first part is mathematical problems, like for example, how fast comets move, like how to calculate escape velocity. You apply very simple physics. You calculate escape velocity. For example, escape velocity from the surface of the sun is this much. So then, what does it mean? It means that at perihelion, what kind of speed the comet will experience. How to calculate that? And here we calculate that it can be up 0.12% of speed of light, and by now we know that it's actually higher. For example, Ison, comet Ison, had perihelion speed of 375 kilometers per second. Of course, it destroyed it most probably because of that it fell apart, but still, sun grazing comets have this much speed. So how much mass there total in the comets? So average comet mass is roughly, and I show these calculations in my book also, how to estimate it, is roughly 10 to 14 kilograms. So scientists estimate that there are trillions of comets in the Oort cloud. So how much mass is it actually? Well, it actually comes only about half Jupiter only. But then, can those comets be source of water on Earth? This is one of the other problems that I suggest. And how many comets would take? So Earth oceans contain so much kg of water. For example, how many Halley's comet are needed to fill the oceans? Total mass of a typical comet is roughly 10 to 14. Comets, let's say 80% water. And you can calculate 2 million Halley's comets. But Oort cloud has trillions of them. So it is actually possible that comets could have replenished water on Earth. Second part of the book, I suggest to you using my images of the comet from January to October to actually calculate the speed of the comet by yourself, to find the angular displacement from the first image and the last image. We need calibrated images. That is why I provide images for January, February, astrometrically calibrated. But we also describe the ways how to calibrate. So step to do this, how to calculate the speed, find celestial coordinates in images, find the angular distance, find the time when it was taken, find the physical distance in kilometers. So, and then find the speed. The actual distance to the comet, of course, we need to know, but it is known by other means. It's usually measured by space telescopes, and it is uh, provided. So here I explain FITS format, astrometry. What does it mean? Astrometric calibration. How to find array and deck in Aladdin. If you can do that. Find the angular distance between two positions. You can use this long formula. If some people like mathematics, they can use it. But these days, of course, everything is online and nearly automated. So in IEA has so-called CADs, where we put astronomical data in software, and there is angle separation calculator. Here you put your array deck of one object, array deck of second object or second position, and you get the angular separation. So it's easier than using this long formula, though it may be more fun for mathematical oriented people. Then you need to find the time when the images were taken from feeds headers, and then you find physical distance. The distance for a particular distance to the comet can be found from the NASA JPL online ephemeris website. And for example, let me try if it works. Sorry. Uh, okay, which is this one? Horizon system. And here in table settings, you can put heliocentric range and range rate, and observer's range and range rate. So this way you will get astrometric array deck, apparent azimuth, and elevation to see from any position on Earth, and you get the distance in AU and in kilometers per second. Okay. Sorry, how do I get out? Okay, yeah, yeah, sorry. Now, then speed is found as usual, physical distance over time. Now, this is the speed of the comet projected on the sky, a transverse component of the comet's velocity. Now, what we would like to find is actually actual space velocity. This is a usual, we need to know the radial component, which is this one. And radial component is provided by the same GPL horizons, what is called line of sight velocity, delta dot. And then using the usual Pythagoras theorem, you find true space velocity of the comet. Now, about astrometrical calibrations, you actually can do astrometric calibration of the images yourself. There are several ways to do it, and trust me that you doing it yourself is fun. The greatest way is Aladdin, where you input X, Y positions and of several stars around, and then create the solution by matching stars with actual image of, let's say, DSS from Deep Sky Survey and your image. Or again, now things becoming very easily, you can use the web net, you upload your image on astrometry.net, and it will calibrate for you. Like, for example, it will provide you new fits image will be already astrometrically calibrated. So this data from January to October, both calibrated and uncalibrated, I uploaded to the GitHub along with the book. So anyone can download it and have fun calculating the velocities. And actually, what I also wanted to say today is now this project, anyone can discover a comet, not just observe it when somebody else discovered it. For example, using SOHO observatory. In 25 years, SOHO was not actually designed to find comets, it was studying the sun. But in 25 years, it found more than 5,000 comets. And a lot of these comets were done by citizen scientists. Here, amateurs looking at SOHO images found 76% of new comets. As you can see, here you can go there and they will show you the videos. You go through the videos, go through images, and comets will be seen. For example, there was a news that Soho's 5000th comet was found by a Sungrazer project participant from China, and he was amateur astronomer. One of the projects, oh, he was like youngest comet discoverer. And he says that he discovered nearly over 200 comets using this Sungrazer. I think this is the video that how it goes. So they provide these videos on the website. You have to observe them and look for something which is similar to the comet. So this is official guide to Soho comet hunting, and everything is explained there. So, in fact, now there are papers uh, which include writing about amateur astronomers finding comets. Like, for example, comets, seeing the bigger picture, maximizing the contribution of amateurs in 2020. Or amateur observers program for 46 for Virtanen. Or amateur astronomers in support of observing campaigns. So, but now what I would like to say that why do we need to continue observing comets? Like once we observe the comets, I mean, what I mean is like you got the comet, you took the video, and okay, you got the image, you got them. Why we have to keep observing it? Well, like I want to repeat that comets are like cats; they have tails and do exactly what they want. To start with, for example, we know that usual um, size of the comet nucleus is something like this, between 4.7 miles to 10 miles, 1.2 miles, something like this, 15 kilometers, let's say. But actually, just recent news came that giant comet was found by Dark Energy Survey. It's called BB comet. It's difficult to pronounce it. Bernard BB comet. So its nucleus is at least 80 miles across. In some places they write 200 kilometers. It is so large that it was originally mistaken for a dwarf planet. Then observations showed that it spotted the tail or coma. Hubble observations showed that comet's nucleus is the single largest nucleus astronomers have ever detected, and its color is blacker than coal. Its mass now is estimated to be 500 trillion tons, 100,000 times greater than the mass of a typical comet of Menor. It will miss our planet by approach in is in 2031. That is why we need to keep observing it to see how it works, how it moves, how it loses. So now there is a huge call all over the world to everyone to observe it, or to at least prepare for its observations, for its arrival. Then another funny news that this same Tushin Chan that we want to see from Bangalore, the paper came in July by Sikanina, who is very famous comet guy, that this incoming comet might actually fall apart. He said that several lines of evidence point that it's inevitable collapse. Well, large comets like Ison, for example, well, Ison was not very large, but still, they normally fragment at perihelion. And it, for example, a comet White 4 2019, it was ripped apart also. And this is this Y4 comet in 2020, and this is Comet Ison, taken by these are Soho images. So other astronomer says that to use the word inevitable in any prediction about comet may be unwise. As you remember, they behave the way they do what they want. However, this new paper, the Sekanina's paper, is another good reason to keep observing this comet at every opportunity. So people, please observe this comet as much as possible. Let's prove it either right or wrong. Will it break apart? Will it not? So then I want another news I would like to share that another bright sun grazer comet is coming, and they say that it could be even brighter than this Tusinchan. It may shine brighter than Venus. This is S1 Atlas comet. So it will have perihelion on October 28th, and the brightness they say could be minus 8.3, which is really unbelievable. There are this news which I would like to also share. This, of course, will be available to everyone about why you suddenly now need to see two brilliant comets. And I welcome everyone to please go and read this. So that is why we have to keep observing comets. And I would like to attract your attention to on our in IAA we have a special page for the comets, all the comets that I observed since 2013. Here's and with the data with the data about it, with different science about it, even some we took spectra, and the book is also here. But data is the data for the book. The data is on GitHub. So here I would like to share also useful internet resources, and some of them I use a lot, like for example, JPL Horizons web application, object visibility. It's extremely good. It's very useful. And there are recently I found that Comet toolbooks, numerical simulations of cometary dust tails in your browser. It's also very interesting. This is new thing for me, and I'm still exploring it. And I would like to, since some of you people are specialists here, I would like to your advice. So I have this strange track. This was taken on Hanle on 13 November 2018. This was observations of Chiron, and we have I have many images like this with the satellites going through. Those I have a lot, even sometimes 3 satellites in parallel. But here, what I would like to ask is this doesn't look like a satellite. It doesn't look like an asteroid either. Asteroids I also saw many. One my student from Christ even did his master's on detecting asteroids in my global cluster images. There were several. But here, this is the close-up of this track, and with even size in Aladdin, you can measure the size in arc seconds, of course, of, and it looks like something is rotating, maybe, and then reflecting light, but not. Here is this very strange jump. And what is interesting that I roughly at the same time it happened, maybe 1 year after, I came upon this video, and I hope we have few more minutes uh, for this video. Here I try to check for the asteroids search, and there is in Aladdin you can do this asteroid search, and nothing follows this track. This was the Chiron, the observations of Chiron, and nothing follows this track. So, but however,
UK's North Holt Branch Observatories recently shared a video which shows an object orbiting the Earth in an unusual retrograde orbit. It was noted in a Facebook post, its orbit is highly elliptical. Since the observations point to the object being extremely lightweight, it falls into the category of empty trash bag objects. It's probably a metallic foil left over from a rocket launch.
as you can see how it moves. That could it be possible? Could it be the that trash bag, because it rotates and it reflects, just like what they showed in the video? Uh, I did some small investigation. This was not ISS for sure. That I discovered. I found that ISS was far away from Hanley at that time. So, but here it is. I can provide all the images and some kind of small information that I found about this, and I would be happy if somebody can help uh, with it. And here is just last slide, some example of magnitudes. That why do we think that -8 is a lot of this comet for new comet? Okay, thank you for listening.
Thank you, madam.
Uh,
Uh, Mangesh, can you take up the uh, If there are any question answers,
Yeah. So Margaret ma'am had opened the session for question answers. Anybody has any questions, please come forward with your questions.
And of course, I will be very happy to share this PPT with everyone who wants.
Yeah, yeah, please. Anyone has? Yeah, Dhruv, you can go ahead.
Yeah, good evening, everyone. I hope I'm audible.
Yes, yes.
yeah.
Okay, great. Uh, Good evening, ma'am. Uh, there was actually I had three doubts. Firstly, you had mentioned that water uh, came means there are hypotheses which state that water must have come to Earth via comets.
Yes.
Am I right?
Yes, yes.
Yes. Uh, the other day I was watching a video. Means it was actually a seminar, not sorry, seminar. Sorry, it was a lecture in which one of the scientists from PRL, Physical Research Laboratory, Ahmedabad, uh, he was giving a lecture or talk about minor bodies, and at that time he mentioned that new research is stating that water was not brought by comets, instead it was brought by asteroids. What is your opinion on this? I mean, is it possible?
No, no, no. Yeah. So I actually this is not exactly correct because we know the composition of asteroids. Asteroids mostly do not contain up to 80% of water. Comets, we know for sure that they contain up to 80% of water. And we know that comets do bring water. But there is a new research which says that most probably water on Earth is actually indigenous. Because recently, just last week, I think, or 2 weeks ago, there was a research showing that discovery of the under like subsurface amount of water, which is nearly 700 times larger than all the Earth oceans. That it is quite possible that the water, and that water is not in a liquid form. That water is locked in the rock, in the mantle. That it is possible that that water was preserved uh, in uh, in the Earth during the late heavy bombardment and during the this lunar impact making impact. So it is possible that that water was intrinsic to Earth uh, after the origin of Earth. But comets did bring some water, and that we know for sure. Unlike asteroids, no, I don't agree with that.
All
Asteroids,
right,
we know they don't have so much water. Asteroids are mostly rocky.
right, ma'am. Okay,
Organics, yes, organics they do have. Organics asteroids do have, but water, no.
all right, ma'am. uh, Ma'am, following this, I had actually one more doubt. As we know that primarily comets tend to have two tails. One is the dust tail and the iron tail.
Yeah.
But the other day I was reading this book, The Great Atlas of Comets, and
Mhm.
there it was mentioned that it had about there were some comets in the past that have been noted, have been made note of astronomers, and they were having more than two tails. That is, I think one had six tails, maximum of six tails so far. So, like, is it possible? And if so, how?
Six tails.
Yes.
Well, yeah, that is a bit difficult to understand. What I know that there are what we say that basically there are several types of tails. Yes, there is dust type 1, type 2, which is dust and ions, but there is also few in like my I have a I'm not professional astronomer, but I have colleagues with whom I work. So they say that in dust tail may have few types of different tails depending on the what kind of dust it is, what kind of matter it is. So that is possible. So, but it is still within the dust tail. It is still, I mean, mostly. But there is also, maybe you heard about anti-tail.
Yes, ma'am.
Anti-tail, of course, that is a projection effect. Anti-tail is, of course, a projection effect due to
Right.
comet going around. Uh,
Yes, ma'am.
but basically it's just dust and ions, and within the dust and ions there are few distinctions which professional comet astronomers they do this thing, but for us it is very complicated.
Right, ma'am. Okay.
Depends
And
on the species.
okay, all right, ma'am. And one last thing. This might be a bit absurd, but can like amateur astronomers like us also access data from Hanley? I mean, it's a bit vague of a question to be asked, but can the data from the Hanley telescope be accessed by us, by regular people?
No, unfortunately, it is not. That is the problem. That even last meetings in IA, we were talking about creating the actual archival data. There is no even proper archive. In,
Okay,
like, for example, Kodai Canal data, it seems it is open to the public. You please check.
okay, ma'am.
Last I saw it, like last year it was not I mean it was accessible only from inside IAA, but I think this year I checked, they were saying that now it is open to the public, and that is data for more than 100 years. So that they say that it is open, but even Kavalur data, VBO and Hanle, no, there is not only for not only for outsiders, even for IA there is no no archive.
Okay, ma'am. Uh, I think Kodaikanal data is for the solar part, right? Of
Solar
regarding the
part,
sun.
yes, it is
Okay.
solid data. Yeah, it is solid data. But at least it is a first good step in the right direction.
True, true, true. Okay, ma'am. That's it from my end. Thank you. Thank you so much.
Yeah, Amratanshu, you can go ahead.
So, greetings, ma'am, and thanks a lot for such a wonderful talk, ma'am. Actually, when you were giving the talk in the beginning of your presentation, you were just giving a little bit of word about the orbit of the comets and all those.
Yes,
So, what I have understood is that is comets which are pulled towards the sun. Sorry, by the gravity of the sun and the planets, they are pulling it towards the sun, which are causing them to descend from the origin, which may be Wood
yes,
cloud or KP Kuiper belt in a highly elliptical orbit. Now, what I have understood is that is probably you can correct me if I am wrong. Sun is at the one of the foci of the ellipse. Now, and over the orbit in which the comet is making, but if you look at the other foci, the second foci, then it is, you can say it is probably empty. Now, my question or my query is, what I understand is comet make a curve around the sun because of the sun's gravity. But
yes,
out there in the outer space, that is when it is at the, you can say, far portion of that particular ellipse, what is causing the comet to curve again and head for the sun in the closed orbit? Is it
yeah.
another
So
star or what could it be?
yeah, so this is how this is precisely the difference between uh, what we call hyperbolic and elliptical orbits. That is precisely the difference between comets from Oort cloud and Kuiper belt. Or there are comets which have, like for example, Encke. Comet Encke has some 3.5 years only orbit around the sun. So when the orbit is closed, like like this, so that is elliptical orbit. But every orbit is, I mean, our solar system exists due to because of the sun, isn't it? Even a Oort cloud exists as it is because of the sun, because of the sun's gravity holding it. Or cloud far away, but it exists only because of the sun gravity. But it can be disturbed. So actually, if everything would be like perfect and normal, ideal, let's say, comets will like planets will keep on going as they are around. There is no disturbance, but there are outside features. Like, for example, something like Schultz star. Maybe you heard about it. 76,000 years ago, there was a star which actually passed through the Oort cloud. and we can imagine how much disturbance that created. So there are a lot of things going around and create the disturbances which nudges those of their circular part, because Oort cloud is roughly spherical, and they can go out. But most, of course, sun gravity, Jupiter gravity is also important. It takes them inside. Yeah. So now this depends on the speed, escape velocity. Remember what I said. Why, for example, Borisov comet came in and went away, and it will never come back again? Because its velocity already was much higher than velocity of escape velocity from the solar system at that distance. As you know, escape velocity also depends on the distance to the central body. The same thing. So comet, if it is hyperbolic, it means it goes like this and goes away. It means it goes too fast. If it is elliptical, it will go slowly, and then sun's gravity will catch it up. It is not going too fast, so sun's gravity will catch it up, and it will go away, but it will slow down, and the orbit will become elliptical.
Sure.
So I
Thank.
hope.
Yeah, yeah. Thank you, ma'am. And
I
so
hope.
there is one, ma'am, one more complimentary query. It may be childish query, but it is emerging from this. See, ma'am, when we are talking about asteroids, we talk about Earth-crossing asteroids, that is potentially hazardous asteroids.
Yeah.
Now, these comets are also, you can say, unusual object. Unusual means they are not so regular. So, ma'am, have you heard, or are there any chances that there could be a comet which could cross the Earth's orbit, which could be deemed as potentially hazardous? Are there any possibilities, even though it may be 0.01 out of 100, but is there any possibility, ma'am?
That's a good question. The only thing that we should understand that, remember I showed you the sizes of the nucleus. So usually it is about, let's say, 10 kilometers, and what we 15 kilometers, and what we call it is dirty snowball. This is not pure rock. Even the nucleus of the comet, unlike asteroid, is not pure rock. It's a mixture of organics, dust, water, ice, methanol, methane, ice, and so on. So even if it hits our planet, comets cannot create too many problems. Unlike, of course, the new BB comet, that's why there is so much noise. But then, thankfully, it will be a billion kilometers from us. So no comets in that sense. And what I said, comets are the largest objects in the solar system, and its tail can go up to several AU, but most of its tail is actually vacuum, as you can imagine. We can see it only because of reflection of light, but most of it is actually vacuum. So comets are not a danger, not like asteroids. Asteroids are much worse.
Okay, thank you, ma'am. Thank you.
Yeah, Vijay Kumar, please go ahead with your question.
Good evening, ma'am.
Good evening.
It is a nice talk, madam. I have one question. When it is this comet getting entry to the towards sun, is there any Jupiter's gravity plays an important role bring towards the sun?
Oh yes, yes, of course, yes, yes, that is true. In as we Jupiter is actually called as the savior of Earth in some sense. So
Yes, ma'am.
Jupiter deflects a lot of such, and we know that the comet Levi Shoemaker, it's actually was its orbit was disturbed by the passing it, because it was passing closer to Jupiter. As you know, Jupiter is also going around. So in case that one comet comes this way, Jupiter comes far away, then Jupiter will do nothing. Comet will continue going to the sun. But if it crosses the Jupiter very close in its orbit, Jupiter will deflect it. Absolutely. And we know it that because we actually in 96, everyone, the world observed it, how the comet was deflected and even collided with Jupiter. And it is known that Jupiter also, in that sense, keeps on deflecting some asteroids away from the in the solar system. That is also known. Yes, in if you're lucky and Jupiter orbit or asteroid orbit passes close to Jupiter, Jupiter will protect us.
Thank you, madam.
Ma'am, one more query, that is, when you were talking about the you can say unusual speeds of the comets, you were saying that comets can go at fast as far as to point two of u, no sorry, c, that is the speed of the light. Now my question is, when you were referring to the speed of the comet, was it in a general term that you were referring, that is in general they are very fast, or in fact when they are nearing or falling inwards near the perihelion by the virtue of the sun's pull or the gravitational potential, then they move faster?
Well, they are like with the example of the Borisov comet. We know that why, as you said, uh, it was moving too, as like IU said, it was moving too fast. Yes. See, what I want to say that escape velocity from the solar system depends on the distance to the sun. Of course, escape velocity closer to the sun is higher than escape velocity far away. So if far away from the sun, escape velocity, oh sorry, the comet velocity is already higher than it is its escape velocity, then it is obviously that it is not a solar system object. It means it came from outside.
Sure, ma'am.
So, but in comets that go what we call sun grazers, is comet which actually pass so close to the sun that they even sometimes touch it and they fall apart like ozone, or they directly impact into the sun. So those comets, those speed, the speed of those comets are due to their very close passage to the sun. Yes.
Thank you, ma'am, for this answering this query, and thanks Triple A Bombay for this wonderful session.
And I would like to, I don't know how to share in the chat. Is it possible to share the document that
Yeah, you can
how to
share it on chat,
upload?
or you can send it on email. We'll share it to the group.
Okay, I will upload the ephemerides of this Tushinchan,
Yeah.
which I calculated for Bombay and for Bangalore. I would like to upload.
Okay, okay. That would be great.
Yeah. So I will send to Bharat then
Yeah,
by mail.
yeah,
Because in chat I don't see how to
yeah.
how to share the document.
Sure.
No.
Yeah. Over to you, Bharat sir.
No, Mangesh, you continue.
Okay.
And from my side, I have to thank Margarita uh, for your very wonderful talk. Only I have to say that now we look forward to you in person in Bombay and listen to your bigger talk sometimes. Thank you.
Thank you.
Mangesh will take over from me, and he will also thank you and the participants for giving us an opportunity to talk to all of you, because we are also in process. Every month on a second Saturday we conduct these lectures.
Oh wow.
Uh,
Please share with me always the link.
Sure, sure. And other reason why I have to say this is we are also looking for younger people to join our group as member, not only as members, but we need some members to become our committee members so that the future is assured. So I request all of you to think about and join us as a part of amateur astronomers, and let us continue this activity not only month wise, we will also have some programs wherein we will have a much better understanding. And Mangesh, you can continue and thank all of you for being such a great help to me. Thank you.
Thank you. Thank you for inviting
Thanks,
me.
sir. Thanks, sir. So, Malrata ma'am, it was a great lecture. I mean, as we said, comets are like frozen time capsules, helping us to learn about the early days of our solar system. And this comet, the current comet, what we are able to see with our naked eye, is giving a very promising aspect that definitely in next couple of days, everybody from at least from the northern hemisphere should able to see the comet in the western sky. With that, I thank you for your interesting lecture on this, and we'll keep in touch with the progress of the comet getting visible in the western sky. Thank
And
you.
what I would like to also to say is that to convey to always to youngsters that science is fun, is also fun.
Yes, definitely.
Not just it is important. It is important, of course, but it's also fun.
Yeah, definitely. Thank you, ma'am. Thanks, everyone. With that, we'll conclude the session today. Happy Dasara once again to
Happy
everyone.
Dashera.
Yeah, thank you.